Now let's look at next magic method call. Magic method call allows to create objects which are callable. If there is no call method in your class, the instance of your class is not callable. Let's see an example to understand what I mean. I have taken the same old example of class player. Now in main I have created an instance of class player. Now when I try to call object 1 like I do call functions and methods, Python returns me an type error that the player object is not callable. Now my class player contains call method and it returns both instance variable name and health as tuple. Now in main when I call object 1 like I do call functions and methods, object 1 returns me instance variables name and health. My object can also have parameters like functions and methods as shown below. Note any class in Python that has special method call is also known as functor. Now let's see next magic method contains, which can be used on containers like list, tuple, dictionary, etc. Again I have class player and my init method takes 3 arguments, object itself, name and health. In main I have created an object 1 of class player. Now suppose if I want to know whether my instance variable name contains a particular substring or an alphabet, I can call in operator on my object. Unfortunately, Python returns me type error message. To check whether my instance variable name contains a particular substring or an alphabet, I have implemented magic method contains, which takes item as a parameter and calls in operator and return either true or false if item is in name or not. Now in main I can use in operator on my object 1. Now let's see next 3 magic methods, iter, next and reversed. In Python we have 2 different types of objects, iterable and iterator. In a nutshell, iterable is an object that has an iter method and it returns an iterator object. In other words, iterable object can be used in for loops, whereas iterator is an object that has also next method and it returns the next element in the iteration. This may sound complicated, but it is not. I have added a link in the description which explains both iterable and iterator objects in Python. Whereas magic method reverse returns a reverse iterator. For example, if you have a list of integer values in ascending order, reverse method returns the list in descending order. Let's see an example of all 3 methods. The init constructor of my class count takes 3 parameters, the object itself, start and end value. The magic method iter returns an iterator, which is any object with next method. In my example, I am returning self, so Python calls the next method which I have implemented below. My next method returns the next value in iterator till the current value is equal to end value, otherwise it raises stop iteration exception. In main I have created an object of class count, and in for loop I am printing each element of sequence. Similarly, I can iterate over my object using next method. In my next example, I have implemented reverse method and I print the sequence in reverse order. As compared to last example, I have only changed the logic of my next method, and the reverse method like iter method returns self. Now let's look at getItem, setItem and delItem methods for containers. GetItem method is used to access an object sequentially, or by using subscript like object and square brackets. It takes 2 arguments self and key and returns a subsequence or an individual item by key value. The key can be any Python object, but it is typically an integer. Let's see a simple example of getItem method. My class counter contains initializer method, which takes self and list as arguments. The getItem method returns the single item of list by index. In main I have created an object 1 and in second line I am printing the list attribute by index. In addition to indexing, I can also use my custom object in a for loop, or I can use the slice expression. The next 2 methods setItem and getItems are called when you assign a value to an element, or when you call the del method as shown below. Unlike other magic methods we have seen so far, getAttribute method is only invoked when you attempt to access an attribute that doesn't exist. So the getAttribute method can be useful for catching and redirecting common misspelling, and giving warnings or raise an attribute error exception. In the following example, my class count has no getAttribute method. Now in main, when I try to access both instance variables myMin and myMax, everything works fine. But when I try to access myCurrent attribute, Python gives me attribute error. That is, count object has no attribute myCurrent. Now my class count has getAttribute method. Now when I try to access myCurrent attribute, Python returns me whatever I have implemented in getAttribute method. In my example, whenever I try to call an attribute which doesn't exist, Python creates that attribute and set it to integer value 0. Now let's see other getAttribute method. If you have getAttribute method in your class, then this method is always invoked if attribute exists or not. So why we need getAttribute method? One good reason is that you can effectively prevent access to an attribute and make it more secret, as shown in the following example. Now whenever someone tries to access an attribute that starts with CU, Python raises attribute exception. Otherwise, it returns the corresponding value. In order to avoid infinite recursion in getAttribute method, its implementation should always call the base class method with same name to access any attributes it needs, as shown below. Now if your class contains both getAttribute and getAttr methods, Python will call the getAttribute method first. If getAttribute method throws an attribute error exception, Python ignores this exception and calls the getAttr method. Now let's see a simple example of both setAttribute and getAttribute methods. SetAttribute method can be used to assign a value to an instance variable. The setAttribute method should not try to assign a value to an attribute in a usual way, that is self.name equal to value, because this will result in an infinite number of recursive calls to setAttribute method. The right way is to use the dictionary attribute. The del attribute is the exact same as setAttribute method, but it is for deleting the attributes instead of setting them to a definite value.